Okay, can you see my screen now? Hi guys.
Yeah, we can.
Okay. So now we will move on to the section 2.4, the next chain and average rate of change. So the last time I give you the definitions of average rate of change, right? But I didn't give you some examples to practice. So today I will give you some examples regarding the average rate of change. So it will appear in some final exams. Okay. So examples. First, I need to recall you what is the average rate of change of the functions. The average rate of change of the function f between x equal to a and x equal to b is, okay, sometimes we write a r o c, it's equal to the chain in y over the chain in x. Okay, what does it mean? Does this mean the chain in y is f at b minus f at a, and the chain in x mean that b minus a? Okay, that is the definitions of the average rate of change. Okay, and I will give you the example for this. So I give the function fx equal to 1 minus 3x squared, and I have two given point, x equal to -2 and x equal to 0. So the question is, find the average rate of change between the given point. Okay. Okay, if you have any question, you can instruct me anytime. Okay, the solution is as follow. I will apply the formula of the average rate of change. Okay. So it's equal to the chain in y. That means it's f at 0 minus f at -2 over the chain in x here. That means 0 minus to the -2. Okay. So now we need to calculate the value of f at 0 and the value of f at -2. Okay. So what is the value of f at 0? Could you tell me what is the value of f at 0? Okay, so this easy, right?
Is 1.
Yeah, it's 1. Relate x by 0. 1 minus 3 times 0 squared. So it's a 1, right? Okay. So what is the value of f at -2? So just relate x by -2, right? So what is the value now?
-11.
Yeah, -11. Thank you, Cove. Exactly. So now we have everything. We have enough information so you can get the average rate of change. So relay f at 0 by 1, and f at -2 is a -11, and divide by this number. Okay, so be careful here. So sometimes you make mistake when you change the sign. So 1 minus of the -11, so it become 1 plus 11, right? 0 minus to the -2, so this become 0 plus 2. So be careful. So it is 12 over 2, so it is equal 6. So the average rate of change here is 6. Okay. Any questions so far? Okay.
This is off topic, but are you going to be posting this recording?
Sorry, can you say it again, Vinia?
Will you be posting the recording?
Yeah, you will receive the recording, no problem. I will send you through Canvas. Okay.
All right, thank you.
Yeah, no problem. Okay. So now I will move on to the next examples. So which is difficult. So I will give you the function f at x equal to square root of x, and I need to given point here is a and a plus h. Okay, a and h here is some numbers. Okay, some given number, and the question is find the average rate of change between the given points. Similarly, you do the same like this. First one, you need to write a definition here. So it becomes f at the second point minus f at the first point, right? Over the second point minus the first point. Okay. So to calculate the average rate of change, in this case, you need to calculate explicitly the value of this guy and the value of this guy. Yeah. So what is the value of f at a plus h? Here, that means you relate x by this guy. Okay. Okay. Could you tell me what is the value of f at a plus h? Could you tell me? We have the function f here is square root of x. Now we relate x by a plus h. So what is this?
A square root a plus h.
Yeah, exactly. Okay, thank you, Cove. So this is the a square root of a plus h. Just relate x by this guy. Okay, that will find the function, find the value of this point. Okay. Okay, I use some corner point. What about the value of f at a? What about the value of f at a? Is square root of a, right? Okay. So now we can imply this. The average rate of change is the square root of a plus h minus square root of a over h, right? Because a minus a is 0. So now the denominator is just have the single h. Okay. So now this is, you can finish here, but sometimes they ask you more things, not just the write like this. Sometimes they don't want the single x in the denominators. Okay, you can see the homework tree. You can see the homework tree on Canvas. Sometimes they ask you they simplify your answer so that no single factor of x is left in the denominator. So sometimes they will. Okay, the answer here is correct. The answer here is correct, but sometimes they will ask simplify your answer so that no single factor of h is left in the denominator. Okay, that means if your answer here that is not complete, if this is your answer, if the question is like this, so your answer is not complete. Okay, so you need to do more steps. You need to make some changes in this answer. Okay, how to do this. I will remind you one formula. A minus b times a plus b. So it's equal to a squared minus b squared, right? Okay, so I will use this formula to simplify this average rate of change. Okay. So now the average rate of change here is square root of a plus x minus square root of a over h. Okay. So now I will multiply the numerators and denominator by a conjugate. Okay. So if I see this guy is a and I see this guy is b, so the numerator here now is a minus b. So I will multiply the numerator and denominators by a plus b. That means I will multiply by this guy. Okay. Yeah. So I will guess the answer as follows. Okay. X times to this guy. So now I apply this formula. So we have this guy a, this guy b, this guy a is a b, a minus b, a plus b. So it's a squared minus b squared. So that is this square minus b squared. So over x times to this guy. Okay. So the numerator now is a plus h minus a divided by h times to this guy. Okay. So you see the numerator now is only h over h times to this guy. Okay, and h here and h here you can reduce them, and this you only have one in the numerators, and the denominator you only have this guy. So now you can see the new equations doesn't have the single factor of x in the denominators. Okay, that they want you to do. Okay, if you stop here, so you also get the point, but it's not complete. Okay, if they ask you more a question like this, simplify your answer. Okay, so you need to use the trick like this. Okay, multiply the numerator and denominator by a conjugate. Okay, the technique here is similar, so you can practice more in some homework. Okay, any questions so far? Okay, hope it's clear. So it's just a technique for you to do to simplify the average rate of change. Just a technique. So I also give you some exercise to practice. Yeah, it's not the difficult. It's just the technique. You just practice more and you can do it. Okay. So now I think the average rate of change is I will go to this part and go next to the transformation of functions. Okay, this is very crucial for you to grab the functions.
Hey, Professor.
Okay, question.
Will you just scroll up just a tad, just so I can see a little bit more?
Sorry, can you say it again?
Yeah, will you scroll up just a little bit so I can see a little bit more?
Okay.
You don't have to go that far. Just where it says a root of a plus h squared minus root of a squared. So we could scroll down.
Go down.
Yeah, we can go a little bit more.
Yes.
That should be good. Yeah, I just want to copy the rest of this.
This step from step to step. Okay, you
just those last two steps right there. I just want to copy.
Yeah, it's from here to here, right? From
Yeah,
here
that's
to
it.
here because the square root of a plus x squared, that means square root of a plus x times the square root of because two square root, right? Let me change the pens. So let's so I have problem with the pen. Okay, good question. So let me explain to you. The square root of some number, like square root of a, for example, when you square, right? So it becomes square root of a times square root of a, right? Both square root, okay, so square root of a times square root of a, it become to a, right? You remove the square root now. For example, square root of 2 times square root of 2 equal to 2, right? So here, square root of a plus x, so it becomes to exactly a plus x. And the square root of a squared, that become to a. Is it clear for you, Cole?
Yeah, yeah, that's good. Makes sense.
Okay. Okay. So after that, you see a minus a is 0. So the numerator now is just x single x. Okay. And after that, you reduce. You can simplify x in the denominator and numerator. Okay. And you can do more some practice problem in the homework. So if you have any trouble, you can email to me or you can meet me in my office hours. Okay, I will help you to do the homework if you need. Okay. So we will move on to the section 2.6, the transformation. Transformation. Okay, my pens. Transformations of functions. This section is very crucial for you to sketch some graph of function if you know some basics form, some basic functions. For example, if you know, the motivation is the follow. If you know the graph of some basic functions, like x squared, absolute value of x, x cubed, something, square root of x, something like this. Cube root of x, something like this. How do you know the graph of the function like like x squared plus 4, y is x minus 1 square, something, x minus 3 1 cube, something, y is square root of x minus 2 plus 1, something like this. Okay, how if you know the graph of some basic function like this, how do you know the graph of the function like x squared plus 4 something? Okay, so that is the motivation for the lesson today. So we will learn how to graph these kind of functions if we know just the basic functions. Okay, that is the motivations. Okay, so now we go to the first issue, the first point of these sections. Okay, if we know the graph of the function here, y equal fx, okay, how do we know the graph of y equal to fx plus c and y equal to fx minus c, where c here is a positive number? Okay, if you know the graph of the function fx, so how do we know the graph of the function fx plus c and the function fx minus c? Something like this. Okay, Okay, so we have something to remember. The first thing, to graph the function, the graph of function fx plus c, you will shift the graph fx upward c unit. Okay. To graph y equal fx minus c, so you will shift the graph of the function fx downward c units. Okay, easy to remember. When you plus c, you will move up c units. When you minus c, so you will move down c units. Okay, that is just the rule for you to remember. Okay, I will give you an example to see. Okay, the example 3. Okay, let's get the graph of the function fx equal to x squared plus 4 by using the graph of y equal x squared. Okay. So now I will sketch the graph of y equal to x squared. Okay. Step 1. Get the graph of this one. So I will use the table of value as I tell you in the previous class. Okay, I recommend you to use 5 points when you sketch the graph of x squared, right? So if I start at 0, okay, it's -2, -1, 1, 2, something is 4, 1, 0, 1, 4. So the graph of x squared like this. Okay. So now I will use this graph to graph these functions. Okay. How to do this? I will use the rule now. I will use the rule as I told you. To graph the here, could I move down or move up if I use the rule now? Could you tell me I will move down or I will move up?
You move up. Move up.
Yeah, move up, because here is the function here is plus 4, right? It's a plus, so you will move up 4 units. Okay, you will move up 4 units. Okay, so 1, 2, 3, 4. So the graph of function is like this. Okay. Okay, so you have the function start at 0, right? So you will move up 4 units, 1, 2, 3, 4. That means the new point is like here, and the graph is like this. So you will move the graph 4 units up. Okay. Any questions so far? Okay. So I will give you another examples. So we have had the function, get the graph of function y equal to square root of x minus 2 by using the graph of y equal to square root of x. Okay, so now you need to know you need to know the graph of square root of x first. Okay, in the previous class, so the graph of square root of x is like this. Okay, no, it's not the like. Okay, it's my, oh my bad. Okay, it should be like this. It should be like this. Okay, so now we move on to the next step. We need to move the graph. We need to move the graph. So could you tell me Could I move down or move up?
Down.
Down.
Yeah, down 2 units, right? Yeah, exactly. So here we start at 0, so we move down 2 units here. So the graph should be like this. Okay. It's not difficult, right? Yes. It's just you need to know the basic functions, and after that you will move up or move down, depends on the number here. If the number here is minus, so you will move down. If the number here is plus, so you will move up. Okay. Yeah. Okay, so now we will go to the next point of this section today. The second point. The second point here is, if we know the graph of the function f, how do we know the graph of the function y equal to f at x plus c and f at x minus c? Okay, where c is greater than 0. Okay, be careful, be careful. So some of you might make mistake. The f at x plus c is different from f at x plus to the single c. It's very different, right? Very different. So it's not the same, right? It's not the same. Okay. For example, when I consider the function x squared, for example, f(x) squared. Okay. So f at x plus 1, you can see x plus 1, all of them square. But f(x plus 1) is equal to x squared plus to the number 1. So you see this function here and this function here is very, very different. Okay, so it's not the same. So we will use the different rules, not the rule we learned above. Okay, not the rule we learned above. So now, what is the rule? Okay, I will give you the rule now. To graph the function f at x plus c, you will shift the graph y equal to fx to the left c units. And to graph the function f at x minus c, so you will shift the graph y equal to fx to the right c unit. So be careful here. So if it's positive here, so you will move to the left. If it's the negative here, so you will move to the right. Okay, that's the rules you need to remember. Okay, so I will give you the example right now. Get the graph of the function y equal to x minus 1 squared by using the graph of y equal x squared. The first thing first, you need to get the graph of y equal x squared. So I think this is a very basic function. I think all of you can do it, right? So I will write it down now. So it's y equal x squared. Okay. So now we will transfer to the new one. Okay, could you tell me? So will I shift the graph to the right or the left? Could you tell me what I need to do now?
The right.
To the right.
Yeah, the right 1 unit, right? Yes, I will go to the right 1 unit, right? So I start at 0, right? Yeah, the point 0, so I will go to the right 1 unit. So start 1, so the new function is like this, right? And the function is like this. Okay. Is it clear, guys?
Yeah.
Right. Yes. Okay. Right. Perfect. So I will also give you another examples. Example 6. Sketch the graph of the function y equal to x plus 2. Absolute value x plus 2. Okay, let me see. Okay, absolute value of x plus 2 by using the graph of the function absolute value of x. Okay. So I think the graph of absolute value of x is not difficult to sketch, right? But now I will remind you, very similar to the way you graph all the functions. So you make a table of values, okay? The negative number and the positive number, and see what happened. Okay. So the table here is like this. X, okay, Y. So we have 0 at the middle, negative 1 and 1. So it should be 1, 0, 1. So I put some point here. So the graph function like this. Okay. So this is a function y equal to absolute value of x. Okay. So now I will transfer this function to new functions. So could you tell me what I need to do? We are move left, right, up, down, something. Could you tell me what I need to do now? Left or right, something?
Move to the left 2.
Yeah, exactly. Thank you, Matthew. I need to go to the left, right? But because it is positive 2, so I will move to the left. Right, move to the left. So I will start at 0, right? 1, 2. So the new functions, okay, we write this. The new function should be like this. Okay. So that is the way to sketch the graph of these functions. If you know some basic functions, it's like x squared, absolute value of x, x cubed, something like square root of x. If you know these basic, so you can graph the transformation of these functions. Okay. Any question? Questions? Okay, great. So that is the second point of this sections. So you know the function f, so you move move down, move up, and move left, move right. So now I will combine the rules, compile the rules together, and you will see some kind of problems. It's not easy like this. So you will combine these rules to sketch a graph. Okay, so now we will combine the rule. By the rule. Up, down, left, right, something. So for example, I will give you examples. Example here is 7. So sketch the graph of the function. Sketch graph Oh. The function f of x equal to absolute value of x minus 2 plus 1. Okay. Solutions. So you can see -2 is inside. So that is in minus, right? So you go to the right or the left because it's inside, right? Inside the function. So it should go to the right, right? Give the second rule. And 1 here is outside. So you will go up or go down.
Up.
Yeah, up 1. Right 2. Okay. So thinking in your mind, go to the right 2 and up, go up 1. Okay, of the basic functions. Okay, the basic function here is the function of absolute value of x, right? Okay, the function here is absolute value of x. Okay, so now we will move right 2 and go up 1. Okay, this function should become to. Okay, I will go right 2, right? Go right 2, so that is here. So this function is y equal to x minus 2. And after that, I will go up 1. Up 1. So it should be like this. 1. So go up 1. Start here, right? So I go up 1. So that is here. So this function here is y x minus 2 plus 1. Okay. So you do step by step by like this. So go to the right, and after that go up 1 unit, and you will get the answer. Okay. Any questions?
No.
Oh, okay. So I will give you another examples. Example 7, example 8. Sketch the graph. The function y equal to x plus 1 square minus 3. Okay. Okay, could you tell me what is the basic functions in this case?
X squared.
Exactly. Thank you, Chelsea. Exactly. The basic function now to use here is x squared. The first thing first, when you sketch the graph this function, you need to determine what is the basic functions. So this basic function is easy and simple, so you can sketch the function here. It's not difficult for you. And after that, you will use the rules I mentioned previously, so you can sketch the graph. Okay. The basic function here is x squared, right? So it's not difficult, so I will draw here. So it's like this. Okay, could you tell me what I need to do now? Up, down, left, right, something.
Down 3 and left 1.
Down 3 and left 1. Okay, thank you, Chelsea. Yeah, very good. Okay, minus 3, so you will go down 3, right? 1 in the inside, so you will go, this is the plus, right? Plus, so go left, right? Left 1. Okay, exactly. Use the rule here. Okay, it's a plus, so go to the left. Okay. So now the answer should be like this. Okay, go down 3, right? Start at okay. Go to the left 1 first. Okay, here, right? So the graph of this function here is y as x minus x plus 1 square. And after that, you will go down 3, right? start at -1, right? Go 3, 1, 2, 3. So start here. So the function should be like this. Okay. Okay. Any questions? Okay. Now it's clear for you. And now we finished. And now we finished two main point of this section. So now we only have one main point in this sections. So if we know the graph of the function f at x, okay, the function fx. So how do we know? How do we know the graph of negative fx and f at negative x? Okay, so it's different again. These functions are different. Okay, I will give you an example to see why it is different, why they are different. For example, I will get the example of x squared. You can see negative fx here is negative x squared, right? But the function f at negative x is negative x all of them squared. So it's become to x squared, right? So negative x squared is different from x squared, right? So we can conclude that they are different. Okay, they are different. Okay, so now how do we get the graph of these functions? Okay, how do we graph the function? So we will use this rule. Use the rule as follows. To graph the function negative of fx, we will reflect the graph of these functions in the y-axis, in the x-axis, x-axis. And to graph the function f at negative x, so we will reflect the graph of the function fx in the y-axis. So you can see in the first case, you can see the x-axis as the mirror, and the second case, you can see the y-axis as the mirror. Okay, I will show you how to do it. Example here, example 9, right? Example 9. Okay, so I will ask you sketch the graph of the function negative x squared by using the graph of y equal to x squared. Okay. Solutions. The first thing first, I will wrap the function y equal to x squared. I will use the red color. Okay. So now you will see we need to graph this function, right? So we will relax the wrap in the y-axis. In the x-axis. So now the x-axis now here is the mirror, right? Okay. So now we will relax these functions, right? So that become to this guy. So the blue one is the new function you need to find. Okay. Is it clear now? Yep. Okay. Okay, to grab this, so you need to If the minus, if the minus is outside, you will relate in the x-axis. If the minus inside of the function, so you will relate the graph in the y-axis. Okay. So I will give you another example. Example 10. Sketch the graph of the function y equal to square root of negative x by using the graph of y equal to square root of x. Okay. Okay, I will use the red one to sketch the graph of the basic function. Is like this. This is the square root of x, right? So now I have the y-axis. Here is the mirror, right? It's a mirror. So now the function, the new function should be like this. Should be like this. Okay. It's a green, it's a blue one. Okay. Any questions? Everything clear, right? Okay. So that's all the things you need to remember. Okay. So I will not give you the homework for this week about the transformation of the function, but I will give you in the next homework 4. I will give you the some kind of homework about this kind of problems, so you can practice more in the online homework, the section 2.6. You can go. Okay, I will stop sharing now. Okay, when you go to Canvas, go Canvas, so you can practice more. Okay, you can practice more. Go to the home section, choose the first one, go to this, and you will see some kind of problems regarding the transformation of functions. So you can go to the 2.6 problem. So it has some kind of problem, so you can practice more. For example, they ask you use the graph of y equal to x squared, and after that you will wrap the function like this. Okay, some kind of problem, so you can practice more. And one thing you can check, if you did correctly or not by using the GeoGebra. I will show you how to do this. You can use GeoGebra to check this kind of. I will type it down here. GeoGebra. It's free for you to use. You can use online. Okay, I will give you some things about GeoGebra. You can check by yourself. For example, when I want to sketch the graph of the function fx, the absolute value of x, so you can see it's like this. So I want to check another function like x minus absolute value of x minus 2 plus 3, something like this. So you can see the new function here is like this. Okay, so this kind of this kind of website is very useful for you to graph the functions. Yeah, you can use the graphing calculators, that's fine. But in the final exam or any test, you cannot use calculator or the computer. Here is just the way for you to check your answer at home. Okay. Okay, it's the way to check your answer at home, not in the final exam, not in the test, not in the quiz. Remember that. Okay. This is just a tool for you to study. Okay. Any questions? Okay. If you don't have any questions, so today we will finish soon. Okay. And if you have any question, you can send me an email or meet me in my office hours. Okay, if I don't have any questions, so I will stop the class now.
Professor,
Okay, question?
can we stay after? I just want to like ask, for that last function that we did, y equals, the root of x.
Y equal to, okay,
yeah,
let me share my
Yeah, can we
screen
pull
now.
that screen back up?
Let me share. Let me share my screens. Okay, which example?
Oh, the last one we did.
The last one.
Yeah.
Okay. The last one is example 10. Okay.
Yeah. What would that look like if we had to reflect it across the x-axis? What would the function be? Because we reflected
Okay.
it across the y-axis, but I want to know what the function would look like if we had to reflect it across the x-axis.
Okay. As you can see, this function, right? This function is the minus. You have to see the minus inside, right? Inside the function.
Yeah.
So if the minus inside the function, you will relate the function in the y-axis. Otherwise, you will relate the function in the x-axis. Okay. So I will the red function is the basic function. So the y-axis is this line, right? I will relate this function by this line, so it become to the blue one, right? Is it clear, Cole?
Yeah.
Okay. So for example, now you can see the minus here is outside the functions. Okay, outside the function. So you will see I will relate the function in the x-axis. Okay, that is the blue one here, right?
Okay.
So be careful. So,
So-
you will see the function here is the minus inside or outside.
Right. So would it be y equals negative root x? Would reflect
Y
across-
equal
would
y
reflect
equal
across x?
x, right? You ask question y equal to negative x.
No, y equals negative root x.
Absolute value of x,
No, square root x.
square root x,
Negative square root x.
like this. Okay.
Yeah.
Good question. Okay, I will show you. So the basic function is like this, right? So now you need to relate through the x-axis, right? Because the minus outside, right? So the function should be like this.
Okay, cool. I don't know why when we were doing it, that's how I thought it was supposed to be with y equals
Okay.
square root negative x.
Yeah, because the minus is
Because it's outside. Okay.
Yeah, yeah. Okay, Ahmad, please.
Yeah, I was just wondering if we did attendance today. I joined kind of late because I was having Wi-Fi
Yeah,
problems.
yeah. I make attendance for you. No worry, no worries.
Oh,
I see.
All right, awesome.
Yeah. Okay. If you don't have any questions, so we can stop the class now. Thank you for your attendance. Yeah, bye bye.
Quick question.
A question? Okay.
So for the online homework, I know that if we do it, we get some extra credit, but can we
Yeah,
do it like whenever, or is there a certain due date?
yeah, we don't have due date for the online homework, but you need to make sure that you do every time because we have a lot of homework. So
Okay.
we don't have due date, but extra bonus for you. Okay.
Okay.
I will check.
Hey, Professor, did my quiz come through email?
Yeah, let me check. I see. I receive your quiz, your answer. Okay, that's good for you now. Okay.
Okay, great.
Right. Great. Okay. So. Okay. See you. Have a good night.
Thank you.
Okay. Bye bye.